Okay. Hi everyone. Welcome to this month's Hudi Community Developer Sync call. My name is Shiyan. And I'm happy to have Shawn here today to share some latest RFC designs about bitmap indexing. Um, so just to give a brief background info, this call is to share the latest development about Hudi community. We talk about RFCs, designs, and roadmap items. Yeah, just like a general information sharing regularly. This happens monthly, and we have a website. We have the information that I will share at the end of the meeting to join this meeting. Um, okay, so Shawn, maybe you could introduce yourself uh, quickly.
Yeah, sure. I'm Shawn. I'm very happy to be here today. I'm from currently working under the AWS EMR team, on EMR data lake team. My daily work is to support data lake on EMR specifically. And for me, my major focus is Hudi. And recently, I've been working on adding the bitmap indexing support on Hudi, which is super fun, interesting. So I think Ethan just Ethan reached out to me, asked me if I want to talk about it. Yeah, I'm just really happy to join this meeting and talk about the feedback index.
Cool, cool. Yeah, so yeah, go ahead and start your sharing.
Cool. So I don't really have a PowerPoint prepared, so my plan is to just talk through the RFC I had I have posted.
Yeah,
I
sure.
hope everybody can see my screen right now. As you know this. Uh,
Yeah, we can see your screen.
okay. So basically, this is the um. Try to move people on the left side. Okay. So yeah, so this is basically the RFC is posted. The PR is open. Um, so if you want to check it out on the Hoodie GitHub, feel free to do so. Or if you want to leave any comments as well, that's also very welcome. Uh, with that aside, I think we can get started to the BMAX index. So what is a BMAX index? Just to give a quick background. So a BMAX is you can consider it as a kind of encoding to represent your data. It's especially efficient when it comes to data that has low cardinality, meaning that the column has very few distinct potential values. For example, in the diagram here, you can see a direct example that I had this column gender. Um, and for this column, currently it has two values, M and F. And for M, it's 10010, and for F, it's 01101. It's just a very simple, straightforward example of like how low cardinality column looks like. And basically, actually, I want to comes to this maybe nuance, because like when I was going through the RFC, I mean the design, I usually got this question of asking about like if we only have two, in this case, if we only have two potential values, right? Why don't we just have one BMap and use one to represent M and use zero to represent F? So that's actually related to the BMap implementation that we're using for this design. Currently, we want to use this rolling BMap, which is actually a sparse BMap, meaning that it only stores the position of ones. So the example here is like ones and zero, but in the actual BMap implementation, it should just store the position of ones. So for example here, for columns gender equals male, you should just store position uh 1 and 4. Basically, it's like yeah, you would just store 1 and 4. And in this case, it's also not hard to notice that if it is like sparse BMap, it's also not really possible to do a global node to run like to operate a global node on the BMap to get the BMap that represent F. Basically, since we only store the positions of ones, you have to know the range of the BMap to do a global reverse operation, which is not viable in the rolling BMap. So I want to get that clear before we really move forward. Okay. Uh, After covering the BMAC, I want to talk about like how actually let's have a few examples, like quick examples of how BMAC index can actually help Hudi to prompt the data. So basically, so see, let's use this example again. Say we have multiple files, and then for every different file, we have a BMAP associated with it that's indexed on gender, obviously. So let's say if we have a file that has no male, meaning that it's off, meaning the male BMAP is basically empty in that case, we can simply check the BMAP's cardinality, which is zero. And if it obviously if it equals zero, we can just prompt that file. That way we can achieve data skipping. There are some but that's actually not the most useful use case I want to introduce. I think the most interesting part is that we can actually index using Bitmap index on multiple columns. So for example, if we have multiple columns, then we obviously will have multiple bitmaps. Then when we're doing, let's say, uh, equals to, and we use and to join the equals to predicates together, we can simply fetch the bitmaps for those different columns and then run bitwise and over those bitmaps. And it will be super fast. And then we can get a new bitmap, and then we just check if that bitmap has any one stored in the bitmap. If it doesn't have any, then we prompt that file. It will be much more efficient than just using one column, one index column to do the prompting. Uh, I think I have more examples later, so I'll just stop on that level and continue on with the design part. So I think the most important design part is like how is the index actually stored in the Hudi metadata. So Hudi metadata is basically you can consider it as a key value is stored in key value fashion. So basically what we design here is actually the format of key and what's exactly the value. So the key here is as you can see here, is basically a concatenated string of column names, column values, and file group ID. For file group ID, I mean it's basically consisted of two parts. That is partition path and the file ID. So that it can be globally unique, meaning that for every file group, I'm trying to figure out a way to explain this correctly. So basically, let's say if you have M file group in your Hudi table, and then you have indexed N columns, then the total maximum records Bitmap index records stored in the metadata table should be M times N. I hope mathematical equation can explain the issue this problem better. Uh, Yeah, but basically that's it. For the key, for the value, it's basically a Bitmap. Again, in the diagram here, it says 1 and 0, but it's actually we are only storing 1 since we are using rolling Bitmap. And what we are storing here is actually the serialized Bitmap string. So as I mentioned before, rolling BMS, it only stores once and it's very space efficient. Before serializing and storing it, there are some internal rolling BMS APIs that allows you to optimize it to basically compress it. We can use that and to make sure that the index size is uh, as small as possible. Okay, cool. I think for this part, maintaining the index, I think this part can actually be a little bit trivial. Actually, we can quickly go through this. So basically, when it comes to index, I always think about four different operations to maintain this index that you need to consider. Initialization, basically as in like when you first create the index over several columns, right? And you want to initialize, basically you need to scan all those files and um, convert those to extract the index information from those files. And then you'll come up with the index records. And then you proceed those index records into the Hudi metadata. That's basically the initialization part. For insert, it's like when you're inserting new data, you need to obviously extract the index record from the Hudi record, and then you add the new index record on top of the existing Bitmap index record. For update and delete is actually similar, so I just grouped them together here. It's basically there are new batch of records coming in, and you want to again extract the index record. But here, what's different is that you had to go to the previous version of file slices to check if there are any uh, existing records existing records in the previous file slices, meaning that we'll need to delete the uh, associated bitmap index records from the previous file slices, and then replace that with a new index records. For the delete, it's just we don't replace that. We just remove. We just check the previous file slices and we try to remove the index records that are associated with the records that have been deleted. Um, it may be a little bit abstract at this point, but I think I've grouped I made some definition of some meta operations that will be used very often to define the four operations I mentioned before. And one is the add bitmap position, and second is the remove bitmap position. To help people to understand this easily, you can just consider this as I would suggest you to say a bitmap not really as a one and zero or just one something. You can just think of it as a list of array that stores long positions. And then when it comes back to the meta operations here, add bitmap position is basically you are adding a long to this array. And for remove bitmap position, it's like you are removing a certain position from this long array. Hope that makes sense. And when it comes, okay, and with that in hand, let's go ahead and define the four operations I mentioned before. So basically for initialize, it will be really straightforward. Basically, you will go through the existing, basically when we're creating the index, we'll need to scan all the files. And all the files will be converted to the existing records mentioned here. And basically for every record in the existing record, you need to initialize the bitmap, basically add the position into the bitmap long array. This will be kind of expensive since you basically need to do a full table scan. But yeah, that's the cost of having index. And having index here will also amplify the write operation, which we'll obviously talk about later. Let's go ahead and define the second insert operation. It's pretty similar to initializing the index. It's just instead of, rather than scanning the entire table, we just need to extract, process the records that the incoming records from the insert query or data frame writes, whatever it is. So basically, for every incoming records, we add the bitmap position to the bitmap. And for the update, it's actually broken down into two parts. Basically, as I said, you had to uh, there are two parts of it. If you just look at the pseudocode, for the first, there are two for loops here. The first for loops is basically for any incoming records, right? Like for the new records, we need to add the bitmap position, add the record position to the bitmap. And then we also need to check the associated, uh, because let's say if you change, we have a column A and the value is like value 1, you change this value to value 2, then obviously you had to remove the associated record position from the BMap value 1 because the value has of this record has already changed from value 1 to record 2. You had to, in the old BMap, you had to remove that position. And for the new BMap, for value 2 BMap, you had to add this position back in. This is basically the gist of this logic. And for delete, yeah, it's basically similar to update. It's just like for deleted records, we don't really need to add new record position to the BMap. We just need to remove the record position based on the delete records.
Well, so one question around deletes. So if you delete a record from a file, so that record, let's say if CUW table, that record is removed from the position, then the positions of the subsequent records are going to be changed. So in this case, are you going to basically compute the whole bitmap? Is that more efficient than manipulating the existing bitmap?
I think you can. That's a very good question. I'm actually trying to figure that out. So you can do basically there are two obvious solutions. One is you try to scan the files again to basically recount the positions. And the second is that you basically check the positions and you uh decrease decrease the position after the removed position by 1. I'm thinking about the second solution, but it's also yeah, but then you will have to know the record position when of the delete records when it comes in. Because right now, I think we also discussed offline that Hudi records sometimes it doesn't when the record is not tagged, it does not comes along with the record position directly. You have to scan the files to know the existing positions. That's one limitation I'm facing. So basically, if that's the case, you have to scan the file to know the existing record position anyway.
Yeah, I guess
Uh,
that there are
Yeah.
multiple scenarios. I think it does make sense to scan when there's a like a batch delete that happens. For example, this insert override will replace all the files, all the records in some files or partition. Then you better just rebuild the whole index based on the new file group. Um, and yeah, I guess my thinking is if it's about finding record position, right? Is this the position still is it like valid information you can retrieve from the, for example, record level index? If user happen to have record level index, would
that's actually doable. But right now, my current implementation, I don't really want to couple
yeah,
the
yeah,
implementation of BMap index to with record level index too much. But I
yeah.
think it's definitely a viable option to optimize optimize the flow here.
Yeah, yeah, for sure. I mean, it's only when it's necessary, if it's available. It's not like you have to use record level index. Otherwise, the index is just a bit, looks like a bit too heavy. Um, yeah, yeah,
Yeah.
just some thoughts. But I feel like if user already use record level index, um, yeah, it may be, um, yeah, I guess maybe not because that's mostly for record. itself, but this is a column, like different column, because this column may not be the record key, right? Most likely. Okay, never mind. That's just some random thought that I just had. But yeah, back to the original question. I guess it does make sense for some like batch um operation to rebuild the index, batch
Yeah,
edits. Yeah.
cool. I hope that answers your questions as well, Ethan.
Yeah, I think there can be also some optimization because deletes can happen in different ways. For example, if for CW it creates a new base file, for MR it adds like a delete block. So it does not change the record positions in the base file. So in different cases, yeah, you can think about how to make this more efficient because the design choice here is that how we can update the bitmap index metadata in the metadata table in a more efficient way. So that on the writer side, it doesn't have to, for example, rescan the data if not necessary. Something to consider.
Yeah,
But I think yeah, Raymond's point is right. Like if you're doing batch deletes and then anyway you are writing new files, then might be better to just rescan the file anyway.
yeah. I think yeah, that's definitely a good point. Um, I'm currently trying to. I'm actually facing some issues around the delete paths on my local testing environment. So that's actually one of the component area I'm trying to work on.
Mm-hmm.
Cool. Uh, moving on. Cool. I think we just covered all four operations for the writing the index. Um, in the following section, I think I'll go through the how BMax index will be leveraged to prompt the data. Um, so basically, Hudi existing, I feel like the existing index support in Hudi is the interface is pretty clearly defined for Spark at least. It has a bitmap index support in tree, and you can just extend it, or implement it, and then have like the I mean the base index support base class, and you can extend it to have a bitmap index support, and then ultimately you just need to override the API, and then you can um have the class to put the to do the enough of it to do the related operations to use bitmap to prompt files. So again, I'm using an example here. Um, So let's say if we have a table that we want to select the minimum age where gender equals female and the commute time equals car. And then in this query, we can see like there are two filters, like two equal to filters, which is the favorite type of predicates that for BMAT indexes. Um, First equal to is gender equals to female, and next equal to is commute time equals to car. Then what we do here is to I guess I'll just use a diagram. It would be even more straightforward. So for since we are retrieving two column name value pairs here, basically we are retrieving two BMAPs here. We just go to the BMAP directly, and for BMAP female, for the table above, uh it's I just going, but please do remember that the low level implementation it only stores one. But I'm just going with a flow here, going with a diagram here for easier explanation. So for BMAP female, we have 0, 1, 0, 1, 1, and for BMAP car for the current file, it's 1, 0, 1, 0, 0, and we just need to do the AND bitwise operation here, and then we found okay, there are actually the cardinality is actually 0 after we do the AND operation is done. So we just prompt the existing file. And obviously, if the cardinality is not zero, meaning that we have like two ones matching to the one position, the cardinality will be larger than one, then meaning that we have the data we want in the current file, then we don't prompt this file in that case. Okay, cool. Comes to my favorite part, the limitation and considerations of the Bitmap indexes. So, one big limitation I see for this index is that it may be obvious to notice that like Bitmap index actually can work better when under a row level skipping data skipping scenario. Because like for each record we store the position in this Bitmap, and if somehow we can in the reading index example here that we're checking the cardinality of the entire Bitmap to see if it is zero, and we prompt that file depends on that. But somehow if we can have finer granularity, meaning that we for each bit we say if it is one or zero and decide to if we want to skip that row or not. To do the row level skipping, it will be even more efficient. Row level skipping might be overkill because like when the data is stored on S3, like if you just skip like if you just skip too little data, you will actually be punished by the S3 IO. But like Parquet also has this concept of row group. Basically, it's a bunch of rows, but like it's much smaller than a file. In a single Parquet file, there are so many row groups. If Hudi somehow can support row group level filtering in the future, I believe this index Bitmap index will actually be even more useful. That's one thing. And the second is a write amplification. I feel like that's not so this is not actually specific to Bitmap index. Basically, for every Bitmap, for every indexing type, you will need to deal with some write amplification. The meaning that when you are writing the data, you have to maintain the index like to the four operations I defined in the earlier section. Yeah. And then there is this memory pressure. It's when you are actually reading the data and you are pulling the Bitmap out of the metadata table to do the pruning, even though the roving Bitmap is space efficient, meaning that it's actually very small and yeah, it's memory efficient. But like if you have too many columns that are indexed, it actually leads to memory pressure at some point. So that's something to look out for. And extra storage is also more kind of on the straightforward end. That like to maintain the index, you have to have store the index in the metadata table. And here I actually consider the size of the metadata of the Bitmap index to be maintainable because like as I mentioned before, that M is a number of file groups across this table and N is a column that got indexed. So actually you got like is the space in big O notation is OMN. So I consider that maintainable. But still, yeah, you have to deal with the extra storage. And the last consideration I listed here is actually interesting one. I will be happy to receive more opinions that because currently I think I only plan to support the equal to predicate. There are other options. So first of all, for not equal to, we don't even support that because the reason we mentioned before that rolling Bitmap is a sparse Bitmap. We cannot do globally reverse or globally not on the Bitmap. It's like super expensive and you have to know the range beforehand, which is not viable. And other thing is that maybe we can support or like currently we only support and equal to and to basically join the multiple equals to query filters together to prompt as much file as possible. Um, so the consideration for not supporting OR here is that since is again like since Hudi is doing only file level pruning, doing like using OR here, most of the time I expect after the OR bitwise operation, the VMAP will end up with cardinality that's larger than zero, and ends up not pruning that file. So I don't think that's like a good case for BMAP index. Um, but yeah, so that's kind of limited predicate support is so BMAP is kind of tailored for a very specific use case. Um, but yeah, I also hear some other interesting ideas about like how you can uh because last time when I was discussing with someone from my team, basically his the engineer said that we can somehow sort BMap and to have it more optimized because like we can know the position if the data is sorted and then we'll obviously the BMap will be even more competitive and then we can even use the position in the BMap to do the pruning. But I consider that is like that's really doable. It's just like sorting is very expensive. I don't expect Hudi customer to. I don't want a sorting to be a prerequisite of using VMware Index. Um, but yeah, cool. I think I reached to the end of this RFC. Uh, and I've been yapping for a lot. So please, if you have any questions, please ask me right now.
Yeah, that sounds, yeah, really interesting talk. Thanks for walking through this RFC. I actually maybe I can just quickly just ask for some kind of tips to understand Bitmap indexing. Uh, would you consider this is more like enhanced colon stats? It's
Yeah,
like, yeah,
that's actually a good point.
yeah,
So I considered this before because like um you can think of it that way, but it's still a little bit different. So let's say for um column stats is basically a range, but for BMAT index is a one-to-one relation.
yeah.
Uh, so let's say if you have a column that has like one, you only have five values like 1, 200, like 1 million or 1 billion, things like that. And if you're using column stats on that column, then the pruning efficient will be really low because you have like 1 to 1 billion range. But for BMAT index, you only have five BMATs to look at. So in
Hmm.
that case, BMAT index will be more efficient.
I see. Yeah, it sounds like it would complement what column stats is good at. Column stats can be good if you have like more close like narrow range to target, and then you can filter down to like less row group of files to check. But when people want to use bitmap, is like the cardinality is like low, just like a enum, like a few possible value for some column, and you can easily just identify the like some files that does not have this kind of value, this kind of filtering, right? It's
Yeah,
like the
exactly.
other, okay. It's yeah, it's complementing what Constance is good at, and so when people wants to use this, they would consider the cardinality and choose some column to use bitmap index and some column use column stats, like this kind of strategy.
Yeah, so for different indexing type, I think it's configurable. At least for B-Magnets, it's configurable that you user decide whether they enable the B-Magnets by default is false. It's basically by default is
Yeah,
disabled. And they also need to decide like on exactly which columns do they want to be B-Mag indexed um to
yeah,
get the best performance. That decision is left for user.
yeah. Yeah, yeah,
Yeah.
same like column stats right now. It's people would want to specify which column to have column stats. Cool. Yeah, that's a good point. Um, so when user okay, so since Hudi has multiple types of index, right? When people enable bitmap, and also they could also enable like record like index, and also there's a secondary index that can add more partitions to the metadata table. So are we actually consider like should the query engine look at the bitmap index first or look at the record level index first? Like is there like a sequence of checking in all these index types?
Yeah, I think that's a really good question. So it's actually hard coded right now in Hudi for at least for the Spark indexing support part. That basically for it has a for loop to iterate through all of the indexing support that has been enabled
Mm-hmm.
and go through that list and to use different index to try to prune the existing file slices provided. Um, so basically, it's up to that whether VMware index the order of the VMware index is actually the depends on that list, like where we put VMware index support in that list.
Mm-hmm.
So that's that. I
Yeah.
think one potential optimization we can do is like maybe we can have that configurable as well if users want, because if users want VMware index to they know about their data and they know that BMap index, for example, is the most efficient index for their data set. They can like prioritize using that index. I think that's one potential optimization, but I feel like that's also like out of the scope of this RFC.
Yeah.
Yeah,
Yeah, that's true. Like this is more of a overall how Hudi indexing system should optimize the index lookup process. There should be some strategy or plan to be optimized for if let's say record level index is available, it should look up that first and then prune based on those. I mean, yeah, just use those file groups. Um, it also matters to like what predicate are there. So
yeah,
yeah, if it's not record key, it's in the predicate, then yeah, of course it should go for like other index. Maybe like there should be some hint about the column. Like we said, like the column, if it's a long, like high cardinality column, it should tend to use column stats if it's available. Or if it's low cardinality, go with bitmap index first. So there's some like planning side of uh, optimization for this. Yeah, it's definitely out of scope. It's a bigger design question.
yeah,
Cool, cool. Yeah, so seems like there's some drawback on the storage because this will be even, I guess, costing more space for storage, like even than record level index, because you would need to store like number of column times number of files, while record level index is just um, number of records. Um, oh, sorry, that's not true. Actually, it's yeah, it may not because it's mostly based on column and files. Sorry, I was yeah, bit misled. Um, so okay. So have so the main advantage about bitmap is more like when you have multiple predicates, right? The
yeah,
predicate when you
exactly.
do and this is especially efficient than like checking one column and then another column. So
Yeah.
do you have a benchmarking or something to show
Oh,
how faster this will be?
I don't have any direct data as of now, but I think that's definitely a valid point that pruning rate is actually um it kind of depends on the file sizing. since like Hudi only supports file level frontend, it basically means that if your file is like large, let's say if it has a million of rows, and then you only indexed one Bitmap column, you use only index one column to use Bitmap index, then it's like not really possible for you to just use that one column to filter a file with let's say a million rows. That doesn't really make sense. So yeah, I think you're right that first of all, the most useful case is that you have multiple columns that has low cardinality, and you run queries that use those predicates a lot to use equal to on those low cardinality columns, and just join those predicates. If your queries is like that, then Bmax is perfect. And also it's about the file sizing. That if a table has like many very large files, then maybe B-analysis is not really optimized for that because the proteinate rate will be relatively low compared to you have multiple files, multiple small files in the table.
Yeah, yeah, that's true. It actually looks to me like it's kind of a prerequisite for Hudi to implement role group level like stats or role group level indexing before you actually implement bitmap indexing. It's like because from time to time we ask people to cluster, like do clustering or enable small files handling, right? So that it tends to give you bigger file size, but that will actually make bitmap less efficient.
Yeah.
So it's actually like, yeah, it definitely good to have role group level indexing first.
Yeah, I wouldn't say it's a prerequisite, but it's definitely good to have.
Yeah, yeah,
Yeah,
yeah, sure. Yeah, it's bit just being a bit dramatic, but I mean, just saying, I mean, we want people to use clustering more or small files handling more,
yeah.
but that will kind of meet like kind of make this less efficient. It's like kind of contradicting. So anyway, it should definitely, I'm sure for some use case it would definitely be efficient, regardless of file size. Um, okay. Yeah. Any other question from other folks from the meeting?
So I checked the APIs of the rolling bitmap or bitmap in general. I think it's also better to support the not equals to predicate because so logically you can flip a bitmap by using the not operator so that you flip 1 to 0 and 0 to 1 and then you can do like an AND with other bitmap so that you can support predicates like okay, column 1 equals to some value, like column 1 equals to value 1 and column 2 not equals to like value 2, something like that. Because there are cases where user want to say, okay, I want to filter the rows which like one of the column is not 0, for example. And then
Oh,
you combine that with other predicates. Then in this case, let's say if you store for the second column, if you store the bitmap based on value 0, you can still use that to efficiently like do like so first apply the not operation on this bitmap and then do like an AND operation with another bitmap so that you can know okay the resulting bitmap points to okay which row actually correspond to this combined predicate.
yeah. I think that's definitely doable. It's um yeah, I think that's actually a very good point. Because like then I think the tricky part is basically when you are indexing this column, you have to not only index, you have to not only specify the column you want to index, but also you want to specify that uh the equality
Correct.
of this of the column that you want to index. Um, because if we have the let's say if we have like the not Bitmap store for every column values, it will be really um first of all, the Bitmap index size will increase by a lot, but and also second is that the right amplification issue will be even worse because like for if you're writing you have let's say if you have a column says US states, basically USA have 50 states, and then for when you're inserting any new data, you have to update the Bitmap for every 49 other 49 states Bitmap. So not Bitmaps. I'm not sure if this uh, makes this clear, but I think there are it's actually there are I think this is a very point, of course. There are some trade-offs there. It's just I'm thinking of.
Got it. Yeah, for example, one example is, let's say, like a common example is we have logs of request or response, and you have status code. Let's say status codes have finite number of there are only like finite number of status code.
Mm,
Let's say I only want to understand let's say down to hundreds, then I can do like status code not equal to 200 or status code not equal to 204, something like that. Then
mm,
I can know, okay, then I only need to look up these two bitmap, then I can have like, let's say some other filters, let's say like log type equals to something like log type equals to error. Then this will be useful. Like then you can filter out logs easily.
yeah, that's definitely true.
Yeah, this is one. I think this is one query pattern I use a lot when I look at, let's say, S3 access logs. Then I
Uh-huh.
can understand. Okay, I usually have like five, six filters. I may not want to get all the logs, but I'm specifically interested in particular logs that, let's say, that have errors. So it can be highly selective. Then I think in this case, bitmap index is going to help a lot.
Mm.
Okay. There's another question from Nancy. How bitmap indexing will handle the rollback scenario?
Uh, I think I'm not able to put it handle the rollback scenario. I think it's actually related to the um it's actually related to is how Hudi metadata table will handle the rollback scenario. Um,
Yeah.
Actually, 2 years back, I was working on the DynamoDB indexing, right, for my internship. At that time, I've done some research on HBase indexing,
uh-huh.
and HBase is performing rollback correctly because it is having versioning. So if you roll back any commit, it will have the previous file ID in the HBase indexing to roll back. But I was just looking for the DynamoDB, and at that time, it was hard for us to maintain the version of the indexing because once you perform the rollback, you need to get the older file ID, right?
Mm,
So yeah, this is one case I think you might need to look into. Um,
Yeah.
yeah, yeah. Sorry.
No, I was just saying, yeah, I think that's a valid point. I guess rollback it's actually a matter of how uh, metadata table handle rollback, but also it's it could be very specific to bitmap indexing. You would want to, because if some file groups are rollback, then those bitmap index will be need to rebuild. Um, yeah, I think yeah, just to maybe to plug into the rollback process of metadata table, bitmap index needs to handle this as well.
Yeah, I think that's actually a very good point. It's because the I feel like the operation I defined earlier in like when maintaining the index is still useful when doing the rollback. It's just like how we want to plug that in to the metadata tables rollback
Yeah.
API to make that work correctly.
Yeah.
Yeah.
Cool. Yeah, that's definitely some important part of the RFC. All right, cool. Thanks. That's very useful discussion.
Thank you. Thank you,
Yeah.
Shawn.
Yeah, thank you, Sean, for taking this through. And yeah, feel free to add more comments from the audience. Yeah, cool. All right. Thanks everyone.
Thank you,
Have a
Shawn,
good
for
night.
your
Yeah.
presentation.
Thank you.
All right.
Okay,
Bye-bye.
see you. Bye.